Hello students, so let us continue with chapter 12 electricity. In the previous video you have seen the introduction part of the chapter, and in fact in this video also we'll see it is a continuation of the introduction part only. In the previous video you have recalled many topics which are very important for the good start of the chapter. And you were supposed to learn two things. You were supposed to by heart two things from exam point of view from the previous video. Which were they? Define electric potential and define electric potential difference. So now you know that potential at any point in an electric field is defined as work done to move a unit positive charge from infinity to that point. And you should remember, this work is done against the electric field. You know what is electric field? It is a space around the charge in which its electrical influence can be felt. You know what is electric potential difference between 2 points now? It is a work done to move a unit positive charge from one point to the other. And again remember, this work is done against the electric field. You know that electric potential and hence potential difference, it is a scalar quantity and its SI unit is, yes, what is the SI unit? Volt, V-O-L-T. And 1 volt is equal to 1 joule per coulomb as V is W upon Q. So let us continue with the introduction part here and recall certain topics and learn certain topics which are not directly included in the chapter. Now let us look at these three terms. You must have heard about conductors and insulators. You must have studied these two definitions in your lower classes. You know, conductors are the materials which allow the electric current to flow through them easily. And now we know electric current is nothing but flow of charges. So we can say conductors are the materials which easily allow the flow of charges through them. Insulators are the materials which do not allow the electric current to flow through them easily or which do not allow the electric charges to flow through them easily. Remember students, there is no body which is perfect conductor. There is no body which is perfect insulator. So we have good conductors, bad conductors, good insulators, bad insulators. Okay. Now what is semiconductor? As the name suggests, semiconductors, they allow the electric current to flow through them because they are conductors, but not as good as the conductors allow. It means they allow, but their conductivity or opposition to the flow of current is more than that of conductors. Okay, so semiconductors, if we classify them, if we arrange them in the order of conductivities, conductors, their conductivity, which conductivity? Flow of electric current. Conductors have maximum conductivity, next semiconductors and next insulators. Clear? Now let us learn few terms, important terms. An electric circuit. This is the definition which is in your NCERT textbook. You are supposed to learn this. Electric circuit is a very common word. You know that when electric current flows, it flows through what? It flows through conductors. But and conductors cannot be, just open thing. An electric circuit is a continuous and closed path. Because for an electric current to flow, there should be continuous and closed path. So this continuous and closed path of an electric current is called an electric circuit. And as I have told you, for electric current to flow, there should be potential difference. Without potential difference, electric current cannot flow. So in an electric circuit, whenever electric current is there should be a source of potential difference. And that source is what? Cell or battery, which is used in an electric circuit. So cell or battery which is used in an electric circuit is a source of potential difference because of which the charges flow and hence there is electric current in the circuit. Now you must have seen in any electric circuit we have a switch. And you know what is the purpose of switch? At home also you have switches. What is a switch? Switch is a device using which an electrical device can be turned on or off. It means using which electricity or supply of electric current or flow of electric charges can be made on or off. Okay, it can be started or it can be stopped. So switch provides the conducting link in the circuit. Now you know that switch can be, normally we say on, switch it on, switch it off. On means the device is working, current is flowing. Off means device is not working, there is no electric current. But in your books you will not find switch off, switch on the words. You will find open switch, closed switch. Now when the switch is opened, so open switch means opened, you can write. So when the switch is opened, there is no conducting link. It means switch is out in an electric circuit, switch is off. There is no conducting link and there is no electric current in the circuit. When the switch is closed, we say switch is closed means switch is on. So conducting link is there in the circuit and thus electric current will be there. Okay, so open switch means switch is off, closed switch means switch is on. Now, there are different types of conductors, like we talk about metallic conductors. We know all metals generally, they are good conductors of electricity. So metallic conductors, in metallic conductors, suppose let us talk about atom. I have drawn a rough diagram here. We know that in an atom there is a nucleus which has protons which are positively charged. And there are negatively charged electrons which revolve around the nucleus in different orbits. You know the number of protons is equal to the number of electrons in an atom, and hence the atom is electrically neutral because the total charge of an atom is 0, yes, coulomb now. Okay, because you should say the unit also when you say charge. But remember students, electrons are revolving in different orbits. And as per Coulomb's law, there exists force between the positive and negative charges, and this force is inversely proportional to r square, where r is the distance between the charges. So we will not go in depth here, but just understand that you will study in chemistry that there are electrons which are present in the innermost orbit, and then as we move out, the number of electrons, here in the second orbit it increases, and in the when we talk about the electrons in the outermost orbit, the electrons which are lying in the orbits which are closer to the nucleus, they are tightly bound because of stronger force of attraction between nucleus and them. So compared to the electrons which are lying in the outermost orbit, they are tightly bound. It means if any charge has to leave the atom, it will be the electrons which are present in the outermost orbit, as they are less tightly bound to the nucleus compared to the other electrons. And protons are positively charged, tightly bound by the strong nuclear force inside the nuclei. So remember, in metallic conductors, these electrons which are present here in the outermost orbit, okay, generally we use the term free electrons. So metallic conductors, in the metallic conductors, when electric current flows, we know electric current flows due to the flow of charges. And which charge will flow now? Electrons. So negatively charged electrons flow through the metallic conductor, constituting an electric current in the conductor. Now in electrolytic solutions you will study in higher classes, like in cell or batteries, the solution present is electrolytic solutions. Okay, so in electrolytic solutions, the charge carriers or the electric current is due to positive and negative ions. And in semiconductors, the electric current is due to, or the charge carriers are, holes and electrons. So just remember the names here. You can remember for metallic conductor, electrons are the charge carriers, or for the current they are responsible. Their flow is responsible. For in electrolytic solutions, positive and negative ions, and in semiconductors, movement or flow of holes and electrons is responsible. Now let us see the definition of electric current. What constitutes electric current in an electrical circuit? Flow of electric charges. And through metallic conductors or in an electrical circuits, generally it is a flow of free electrons that constitutes electric current. So we'll be considering this only throughout because we'll be considering metallic conductors only. So electric current is constituted by the flow of charges through the conductor. It is a physical quantity which is measurable. It has formula. There is an instrument which can be used to measure electric current in any electrical circuit. So let us see what is its quantitative definition. Electric current is the rate of flow of charges. You have studied in your 9th class, rate of flow of when you hear the term rate, you know what it is. So generally it is time rate. So electric current is the rate of flow of charges, means just look at this equation. Electric current is represented by capital I, and if I denote capital Q as, I have used capital Q as it is used in your NCERT textbook, otherwise small q can also be used. So if Q is the amount of charge that flows through the conductor or through the cross section of the conductor in time t, if Q is a charge that flows through the conductor or cross section of the conductor in time t, then what is Q upon T? Amount of charge that flows through the conductor or cross section of the conductor in unit time, and it is nothing but rate of flow of charges. So this is electric current. So we can define electric current as rate of flow of charges or amount of charge flowing through the conductor in unit time or flowing through the cross section of the conductor in unit time. So if I is the current flowing through the conductor, Q is the amount of charge flowing through its cross-sectional area in time t, then I is equal to Q by T. So rate of flow of electric charges through the conductor is nothing but electric current. Now electric current, although remember it has direction. Now see, in this case we know that we will be considering metallic conductors only. So electric current is constituted by the flow of electric charges. Okay, and when electricity was discovered, it was discovered that it was constituted by the flow of electric charges through the conductors. It was not known whether the positive charge flows or negative charge flows. So what it was said that the direction in which the positive charge flows should be taken as the direction of electric current. And by convention, the same thing is used now also. The direction of electric current is taken as the direction in which the positive charge moves. But we know that in the conductor actually electrons move, and flow of electrons constitute electric current. And if I consider the electrons are moving here towards right hand side, so what is the direction of current that we take? Towards left hand side. Okay, so by convention the direction of electric current is the direction in which the positive charge moves, but in reality electrons move, and so this convention has not been changed. So we take the direction of current as opposite to the direction of flow of electrons. Remember this. Okay, and in an electric circuit you have a cell or a battery. You know it has a positive and negative terminal. The direction of electric current is always taken from positive terminal towards negative terminal of the cell. So I hope the definition is clear to you, the formula is clear to you. Although it has direction, its direction is not as the direction of a vector quantity. It is a scalar quantity only. And so it is a scalar quantity, it has SI and CGS units. As I told you in this chapter, we'll be seeing SI units only. Okay, so I is equal to Q by T, and you know the SI unit of charge is coulomb and the SI unit of time is second. SI unit of current is coulomb per second. It is given the name ampere in honor of scientist Ander Mary Ampere. So ampere is the SI unit of electric current whose symbol is capital A. And from this equation, we can easily define the SI unit of electric current, that is ampere or 1 ampere. 1 ampere will be equal to 1 coulomb per second or 1 coulomb per 1 second. So how will you define? electric current through the conductor is said to be 1 ampere when 1 coulomb of charge flows through it in 1 second, or flows through its cross-sectional area in 1 second. Okay, hope you know how to define the units by using the equation. 1 ampere is a current flowing through the conductor when 1 coulomb of charge flows through it or through its cross-sectional area in 1 second. Just like coulomb, ampere is also a very big unit of current, and hence you will find in numericals generally smaller units are used like milliampere and microampere. 1 milliampere is 10 raised to minus 3 ampere. 1 microampere is 10 raised to minus 6 ampere. So today I hope you have understood the topics well, and you should by heart this electric. After understanding, you're supposed to learn also this definition of electric current, its formula, its SI unit, and the definition of SI unit. So we'll continue in the next video with the same chapter 12, electricity.